Today we did a lesson on parallelogram area, and I'm going to just do a summary of the notes. So at the top of the reading here, you see that there's a little explanation, definition of what a parallelogram is, and it's a quadrilateral, which means there are four sides and two pairs of parallel sides. So parallel sides are sides that don't intersect. So for example, on this picture here, this side is parallel to this side because they are never going to intersect. They're kind of like railroad tracks. And this side is parallel to this side. So that's what makes something a parallelogram. Our focus today is to find different ways to think about area, and then to use the algorithm to find the area, and also to find the area on a grid without the algorithm and compare them. So when you look at the reading here, it asks us to study the figures below, and we're just trying to visualize one way to understand parallelogram area, to understand where this algorithm comes from. And that stands for A stands for area, B stands for base, and H stands for height. And so we talked about lots of different activities in class today, but to summarize, when you're looking for the parts of the parallelogram that you need for area, you really want to look for the square angle or the right angle. And so as you look through this picture here, one of the things that is drawn here is trying to help you visualize how sometimes you can look at a parallelogram and visualize a piece of it, like this triangle here, and how it fits nicely into this piece right here. And then your new shape, once you move that, you ignore this and you sort of create this new rectangle shape. And that's what this picture is over here. So this is just sort of a graphic of one way to think about parallelogram area. So let's go back to the picture before I wrote all over it and think about how, just to read this graphic, that some parallelograms can be nicely dissected and pieced back together to make a rectangle. And we've worked with rectangle area already, and what we noticed in rectangle area is that we always multiplied the length times the width, because the length and the width made a square angle. So we're going to take that idea and bring it into the parallelogram over here and look for that square angle. And those are the two values we use to calculate parallelogram area. So whenever you do a problem, you have to be really careful in looking at the problem and deciding what numbers you need to use when you're calculating area. And then when you look at a parallelogram, you have to remember that perimeter of any figure is still just the sum of all the side lengths. And those are the values on the rim. So for this picture up here, for the perimeter, we would really just use the base and the sides, but we don't use the H value. So let's just practice using the algorithm. And reading the directions here, practice the skill, find the area of the parallelogram to the left. So anytime we're trying to find the area, we're going to look for the square angle. And I suggest that using a highlighter is a really good way to draw attention to where the height and the base are. So this is the base, and that's the height. And those are the numbers the only two numbers that we use to find area, because area is going to be base times height. Wow, that pen went a little crazy there. And so, in looking at my highlighted values, in my picture to the left, the base is 10, and the height is 4. So when I multiply those, I have the product of 40, and since it's area, it's 40 square inches. And that's the answer. We'll just draw an arrow there. But to find perimeter, my equation is going to be 2 times the base, which is 10, plus 2 times the side, which is 5. So that's 20 plus 10. And that's 30 inches. So this was a review of class, but what was tricky in class was doing problem 3 without using the parallelogram area formula. So what it asks us to do is study the parallelogram and use just the grid to find the area. And so, in other words, imagine that you can't, first of all, see what's behind that. And then second of all, we talked about all different kinds of strategies to find the area without using the formula base times height. And several students came up with this really nice visual of looking at the space that's not blue and recognizing that there's this triangle here, and if I made a copy of it, it fits in very nicely above. We practiced with a different problem, so this is just a summary. And they also noticed that if they pulled those triangles out of the picture, they make a rectangle. And so how is it that that's going to help us? That's the question. So what I want you to remember is that you do know, whoa, that's just too giant. Let me make that thinner. That there's this purple rectangle, and if you look at the grid, you can tell that the area of that purple rectangle is, because it's 4 units high and 8 units wide, the area of that purple rectangle is 32 square units. So I was going to make a picture of that. I only got part of it. Make a picture of the other part. It came in pieces. So that is 32 units squared. And I'm going to just sort of shrink it up. So we know that this is 32. But we also know that the yellow rectangles together, if you look at that, this is 4 units because it fit right in there. And the distance across the bottom is 5 units because it fit right in here. 1, 2, 3, 4, 5. And so in class, people figured out that this whole area is 20 units. So each one of these is 10. we take one of these triangles and make a copy of it, we can kind of show a sort of visual of subtracting out two of those. Each one's 10 units. And so 32 take away 2 times 10 is 32, take away 20, and we figured out that the leftover was 12, so that's what this had to be. So that was the parallelogram area without the rule. That was hard thinking, but it's a fun puzzle, and we'll be using that thinking for bigger problems this week. So the last thing we did was we went to problem 4 and we practiced using the algorithm. So we already know without the algorithm that the area of that parallelogram is 12, but we should be able to verify it with the algorithm, because we like algorithms because they are quick and they're sometimes very easy, but we also like to be able to do problems without the algorithm because it's a good exercise and develops our problem solving skills. So looking for the height in a parallelogram like this, we talked about thinking about this parallelogram kind of like the Leaning Tower of Pisa, and if you were standing on the top of it and you held a string, hopefully you're not like going to fall off of it. Let's move you over here. How would that string fall? Would it fall straight down or would it fall along the Leaning Tower? And because of gravity, we know that string would fall straight down. And that's how we think of the height. The height always has to go straight up and down. So even if a parallelogram is tipped over, the height is still straight up and down. So in this picture, the height of this parallelogram is 4 units. And the base is way over here. It's not even attached to the height. And that's okay. That's 3 units. And so by the algorithm, we would say the area of the parallelogram is the base times the height, which is 3 times 4, which is also 12 square units. So we bring in one more page here and just kind of take a look at our notes. I think that the takeaway is that when you have a parallelogram like this, the height is usually shown outside of the parallelogram, straight up and down like that. And it might have another dotted line that goes to the base, maybe in a textbook. And it probably also will have a square angle shown. And it'll give you distances usually, and our distance here was 3 units for the base, and the height is there. And so even if we knew the other sides to be like another value like 10 units, for the area alone, we would just look for the base and the height. And I think a highlighter can help you figure out what those values are before you start. And then we see the base is 3, well, it kind of disappeared, and the height is 4. So we just multiply to get 12 square units. But if we had to do perimeter, we wouldn't use the 4 at all. We would just add the 3 and the 10 and the 3 and the 10 and say the perimeter is 3 plus 10 plus 3 plus 10, and that would be 13 and 13, or 26 square, or 26 units. It's perimeter, it's not square units. So that's all we worked on today.